In standard position trig, it's really important that we understand that we're focused on the position. And position defined either by an angle, a rotational angle from starting at 0 degrees or the initial arm like that, or the alternative is we can describe the position based on a coordinate. So for example, the coordinate given here of 5, -9. So positioning is based on either the coordinate or a positional angle measured from 0. So it's important to keep in mind that main idea. So here it says the angle theta is defined by the point 5 to the right, 9 down. That ends up in quadrant 4, and that defines the terminal arm. So we want to draw this angle in standard position. So here's the position that we are looking for. Okay, that position is given by the coordinate. That coordinate 9, positive 5, -9. And that same position we're now going to define based on this rotational angle from 0. Okay, so that's our theta. So those are two different ways to describe the same point, either with an angle or with the coordinate, xy coordinate. Okay, so there's the standard position. We want to find the trig ratios, so I need to find sine and cos and tan. To do that, the first thing we're going to do is we're going to find the length of the radius, or the hypotenuse in this case. So I'm going to take the radius squared is going to be equal to positive 5 squared plus -9 squared. And then I'm going to square root both sides, so I get r is equal to 25 plus 81, and that works out to be 106. So the radius of this circle is going to be 106. Okay, so once we found that length, root 106, we can now write the ratios. The sine theta, and sine is always vertical. Okay, sine goes with y. So when we talk about sine theta, we're going to take that -9 over the radius, which is root 106. The cosine theta, cosine goes with x, or cosine goes with horizontal. So the cosine theta has to go with that plus 5. So we end up with positive 5 horizontal over the radius, which is 106. The tan ratio is going to be the slope. So the slope of that line has got a negative slope. The rise is -9. The run is positive 5. So the slope is going to be -9 over 5. As a decimal, that would be -1.8. So here I have my trig ratios. The trig ratios are directional, so it's important that we have positive, negative, up or down, because it's based on the position, not the triangle. So we have our position in terms of the coordinates. Now we have our position, and we're going to describe that position with an angle. So to describe that position with an angle, we need to work out the angle. This is where we need our calculator. So if I want to find the measure of angle theta, I can undo the sine, cos, or tan, or use the arc sine, cos, or tan. So I'm going to use tan. So the inverse tan of the ratio -9 over 5 is going to give us theta. I'm going to call this one theta 1. So I do inverse tan of -9 divided by 5, and that gives me an angle of -60.945, so I'm going to round that to 95 degrees. And that positional angle is going to be the one that is in the triangle here, or measured in this direction, okay, which is perfectly okay. That is the right position. I actually have the right position, so I don't need theta 2. I have the right position, but the question does ask between 0 and 360. So although that positional angle measured from in the negative direction gets me to the right spot, I want to use the other angle measured in the other way. So this is a coterminal angle. So I'm just going to add 360 degrees to that. So I'm going to go plus 360. Okay, so this is not theta 2. This is just adding 360 degrees, and that gives me to the position angle of 299.05 degrees. Okay, so those again represent the same position. One is measured in the positive direction, the other one is measured in the negative direction. So this same theta 1 is going to be, instead of going negative, I'm going to go positive 299.05, and I'm going to get to the exact same position.